Hi everyone, we're going to let sine of theta equal square root of 5 divided by 3, where theta is acute. We're going to find cosine of theta and then find also cosine of 2 theta. So we know that our angle is acute. That means our angle belongs to quadrant 1. All right, because it's less than 90 degrees. Our angle is less than 90 degrees. That means that's in quadrant 1. So to find cosine of theta, we're going to use our identity of sine squared of theta plus cosine squared of theta equals 1. So we're going to get cosine squared of theta equals 1 minus sine squared of theta. There's your sine. So write square root of 5 divided by 3 squared. Now this is going to equal 1 minus 5 divided by 9. And it's cosine of 2 theta. And that's going to be, if you change this to 9 divided by 9, that gives you 4/9. So take the square root of both sides of the equation. Don't forget your plus and minus. It has to be plus or minus 2/3 equals cosine of theta. However, remember our angle is acute. That means cosine and sine are both positive in quadrant 1. So we're only going to take the positive. So that's your cosine of theta. Now we have to find cosine of 2 theta. So for that one, we already know what sine is. And we already know what cosine is, was 2 square over 3. So now all you're going to do is use one of these identities. For our double identities, just use one of those. It doesn't really matter which one. So I will just choose this one for fun. So that one's going to be cosine of 2 theta equals 2 cosine squared. So our cosine is 2/3 squared minus 1. So that's going to be 2 times 4/9 minus 1. And that's going to equal 8/9 minus 9/9 equals -1/9. And that's your final answer. Thank you. Have a nice day. Bye-bye.